All right. So I've talked a little bit about what GuardianAI is, and I'm going to switch focus here real quick and just give you a short demonstration video of what it is and the workflow that a user would experience. So you can see here, the user is going to log into GuardianAI, and the first thing they're going to do is add a new drive and asset that they want to monitor. So the very first step is to give us the information about the drive that we're going to be connecting to and using as the data source. So you can see here, it's drop-down menus, user input. Again, no programming or data analysis required outside of the simple workflow. And if you have one of the drives that I mentioned, again, those ones are the out-of-the-box easy button here. You just select them from the drop-down menu, give the drive a name, and then let us know the path that we need to connect to the drive. And in version 1, we support direct connection to the drive as well as connection through the controller. The second step here is to tell us what information we need about the asset that you're going to be monitoring. So again, we need to give the asset a name, select the type of asset that we're going to monitor. So is it a pump, fan, blower, or are we going to be using motor analytics? And then how many blades are associated with a pump or fan. And then there's some optional information here in the middle the user can supply but not required around what the manufacturer is and part number of the asset. And then there's some bearing information requested as well. If the user has this information and can provide it, we'll give them a little bit more detailed analysis and failure mode identification regarding the bearing. But if they don't have that information available at the start, they can move forward without it and always add it later. All right, so hit play here. All right, and then the last step is to tell us a little bit about the output frequency that GuardianAI should expect to see, so the minimum and the maximum that are experienced during normal operation. The last screen here was just reviewing all the information that the user input, and now we're already ready to start training GuardianAI to understand how that asset performs under normal operating conditions. And I want to highlight here that GuardianAI isn't just going to create one baseline for your asset. It's going to create an individual baseline at every half hertz increment between the minimum and the maximum that you set to understand exactly what that data coming from the drive looks like at every speed. All of this training occurs under normal operating conditions. So we don't expect our customers to adjust anything in their process. They don't need to go through any step changes. It's going to train on whatever speed that asset is running at. And as soon as it completes training at that speed, that one will automatically switch into monitoring mode as we're seeing here. So you don't need to train every single bucket and then move GuardianAI into monitoring mode. It's going to move to monitoring mode automatically at whatever speed is completed. And then if it sees a different speed in the future, it will switch back, train on the new speed, and then move that one to monitoring mode. Under a normal architecture setup, we expect this training for each speed to take somewhere between 15 and 30 minutes on average. So you can see really once you input the information and get this training, you can start showing value almost right away if they run at a few speeds pretty consistently. All right, so
Amanda,
here we can.
A question that came up is GuardianAI able to distinguish between the two different types or the different types of pumps?
The different types of bumps?
Pumps.
Oh, okay. You don't have to necessarily tell us what type of pump it is for GuardianAI to be able to monitor that asset.
So it won't have to distinguish between one pump from another?
No, I do have a slide a little bit later on that will show you what failure modes we can detect out of the box in GuardianAI for pumps specifically, but those would apply kind of across pumps. There's no like this pump versus that pump specific failure modes, at least not yet.
Mitchell, if we don't get your question answered later on, let me know. We'll revisit that. Thank you.
Yeah, thank you. All right. So we completed training for that first bucket. So now I'm just going to show you a little bit about what it looks like for GuardianAI to detect an anomaly. So here we can see GuardianAI detected a deviation. So that means that this asset is starting to drift from baseline. And when that occurs, again, you'll see that alert. An email will be sent to the user. They can come back to the GuardianAI interface and see that this is a deviation. You can see a little bit about how far it's drifted from the baseline. So how significant is it? Is it, in this case, it's drifted 3.45%, or is it a lot more drastic than that? How many times has GuardianAI detected that anomaly? And when did we last see it? Then you can see down here on the bottom of the screen, this is where that failure mode identification comes into play. So in this case, the pattern that we're seeing is tied to some type of process change. It either looks like cavitation or a viscosity change of the fluid. So those are the two recommendations that GuardianAI is providing to the user. The user has the option to select one of our recommended failures, or they can tell us, no, this is normal operating behavior, ignore this, or they can label it as some type of other failure that GuardianAI did not recognize. At this point, we're going to select cavitation and then give GuardianAI some additional information about how severe this issue is for us and the amount of time it will take to resolve that issue. And you can see here, as GuardianAI continues to detect this cavitated state in the field, it's going to build a trend for us. So it's not going to send you a different alert every time it's still detecting that same cavitation. It's just going to build you a trend of how far that issue is drifting from baseline so that you can see how long it's been on that state or in that state and what the drift looks like. So here, I also want to mention, I think we're going to switch screens here and then come back. But so when you label an anomaly, it does move from the deviation category to a failure risk. So when it shows up as a deviation, that means that you haven't told GuardianAI exactly what it is yet. Once we identify that for GuardianAI, it moves to the failure risk category and it will stay there until you actually resolve the issue in the field. And that's when you would come back to GuardianAI and mark this issue as resolved, at which point the issue will clear from GuardianAI and that asset will show back up as a healthy asset. If for some reason you mark it as resolved and the issue is still persisting in the field, GuardianAI will just bring that alert right back to you. All right, so that was the product overview. I had some slides here, but I will skip those because we just saw the product live instead. And if you have any questions about the workflow, feel free to enter those in the chat and we can certainly address them at the end. So hopefully this slide speaks to the question that I just got about pumps and different failure modes that would be detected. So GuardianAI has two methods of providing information about the failure mode to the user. The first is the failure modes that are embedded in the product. So these are, we call them embedded expertise. They're tied specifically to the asset types that I mentioned at the beginning. So pumps, fans, blowers, and motor analytics. And so if we detect data patterns coming from the drive that are associated with any of these failure modes, GuardianAI can recommend those to the user. If it's not completely clear which one it is, GuardianAI will recommend the 2 or 3 that kind of fall in the same category so that the user at least has a starting point to figure out where they should start investigating the issue.
As you're talking about notifications, pardon me, the question came in as notifications through email. Is there a way to notify via HMI?
That's a great question and one that we get a lot. And so that is planned for version 2. In version 1, it's email notification. In version 2, we will have right back to the controller so that we can surface these alerts at the HMI as well. Good question. All right, so if GuardianAI does detect a deviation from normal, but it's not associated with any of these failure modes that I'm listing as part of the embedded expertise, it will still alert the user that your asset is starting to drift from normal. It just might not provide any of those out-of-the-box failure recommendations. The user will then go in and label that failure mode with whatever they determine the issue to be. And then GuardianAI will associate that label with the pattern that it saw. And in the future, if that pattern is ever detected again, it will resurface the label that you gave it. So I really like to highlight this because this talks to the adaptive learning nature of GuardianAI and its ability to learn new failure modes. So the more that you use it and the more context and information you give GuardianAI over time, the smarter it becomes and the more useful it becomes. So it is not static as the products that you purchase on day one, but really becomes more and more useful for the user over time. All right. So again, kind of starting to wrap up the product overview section. Here, I just want to show a high-level architecture, again, of all the components that would be important to a GuardianAI solution. So we have the end asset connected to the drive. That's going to be the data source. It can be connected either directly to GuardianAI, which will be deployed on an edge PC, or it can go through the controller as well. GuardianAI is a standalone software, so it will need to be deployed on a computer at the customer site. We support the edge PCs from Rockwell Automation, but we also will support third-party PCs as well if our customer has a vendor of choice that they're already working with. So you'll find the minimum hardware requirements included in the installation guide on the literature library. There are two different methods of deploying the software onto the Edge PC. So the preferred method is to use Edge Manager. Edge Manager just simplifies the deployment process. It allows our customers to manage both the Edge computer and the GuardianAI application instance over the entire life cycle of use. So helping them stay up to date with like OS updates as well as application updates over time. This can be really valuable, especially for customers as they scale out their use of GuardianAI to multiple instances across the plant or across multiple facilities to make sure that they're all deployed consistently. In the case that a customer is not using Edge Manager or cannot use Edge Manager for whatever reason, we can also deploy the container manually. And so there are user guides for both methods of deployment, as well as demo videos that will be made available shortly that walk you through the steps.